Let's put what we know about the signs of trigonometric functions into practice. In this question, we're being asked to find angles in each case. This part just means that the way we answer this question should give an angle between 0 degrees and 360 degrees. In other words, it's asking for a specific option because we could write these angles in so many different ways. These are all called coterminal angles. In this case, the angle should be positive, not the negative coterminal version, and we shouldn't try to give an angle that's greater than 360. Okay, what have we got in each case? Well, here we're told that the tangent of the angle is equal to 2.05. So we have two pieces of information. We know that we can solve for this angle, and we also know which quadrant we're in. There's no restriction here that says we're in quadrant 1. So with only one piece of information, we could be in quadrant 1, but we could also be somewhere else. So let's look at that second point. Okay, so if tangent is positive, our angle is either going to be in quadrant 1 or, and we'll call that theta 1, it's in quadrant 3. I'm not guessing at the magnitude of these angles here. I'm just drawing a sketch that helps me to picture these angles. Now we can reach for our calculators. To find the value of the angle, we'll take the inverse tangent of 2.05. Doing this gives us a value of 64 degrees. Now, of course, this is just the reference angle. It turns out that it's also theta 1, but we want to be clear that this isn't necessarily our answer and write this down as theta ref is equal to 64 degrees. I'm rounding here. If you're doing this question on MyLab, you're going to want to leave some extra decimal places so that you get the correct final answer. So do as I say, not as I do for a few of these questions. I'm using rounded numbers just to keep the math simpler. All right, so theta 1, well, yeah, that is the angle of 64 degrees. The reference angle in all cases but one, and we'll look at that, is always going to be an angle in quadrant 1 or quadrant 2. And so often, it's a free answer. But for theta 2, where is that reference angle? Well, the reference angle will be here. That's a value of 64. That's the value of 64 degrees. So theta 2 is a value of 180 degrees plus an additional 64 degrees, or 244 degrees. So our final answer is two angles. Theta 1 is 64 degrees, and theta 2 is 244 degrees. Similarly, in the second question, we're given a single piece of information. We're told that the sine of the angle is a negative ratio. So before we get started, let's draw a picture of that. Sine is a positive ratio in quadrant 1 or quadrant 2, so we must have either a quadrant 3 angle, theta 1, or a quadrant 4 angle. I'll call that theta 2. Now that we're situated, we can go ahead and find the reference angle. We'll do that by taking the inverse sine of both sides. So theta is equal to the inverse sine of negative 0.5736. So theta is equal to negative 35 degrees. Again, I'm rounding far too early. Where is negative 35 degrees on our coordinate plane? Well, negative 35 degrees is here, so we're given a reference angle. And that is in fact the value of theta 2. But we're not going to give this as the value of theta 2 because the question specifically told us it wanted an answer between 0 and 360 degrees. So we are going to treat this as a reference angle. So I'll write theta ref is equal to positive 35 degrees. I tend to give my reference angles as positives because I'm going to be working with them anyway. They're not the final answer. All right, so theta 1. Theta 1 is the quadrant 3 angle. So the reference angle is down from the positive x-axis. And theta 1 is 180 degrees plus 35 degrees, which takes us to 215 degrees. Theta 2 is 35 degrees shy of being 360 degrees. So we'll take 360 degrees and subtract 35 degrees to get a value of 325 degrees. Again, we were given one piece of information, and therefore we have two possible answers. These are the odd ones. So in this case, we're given one piece of information, but we'll find that when we have a cosine ratio that is negative, we're not given our usual reference angle. And in the second question, we have two inputs, which helps us to narrow down our options. We'll only have one answer for the angle. As before, we're asked to quote our answer as a value between 0 and 360 degrees, so a positive angle. Let's look at that first one. Let's start with a picture. So the cosine of an angle is negative in which quadrants? Well, it's positive in quadrant 1 and quadrant 4. So this time we're in quadrant 2. I'll call that theta 1, 4, and quadrant 3. This is the only case where we don't have a quadrant 1 or quadrant 2 angle. So this is the only case where when we punch this into our calculator by taking the inverse function, we don't get a value that is between 0 and 90 degrees and 0 and negative 90 degrees. We have to be careful in this case not to change the positive or negative sign that we're given. So inverse cosine of negative 0.422 is 115 degrees. If we had decided, no, I'm just going to find the reference angle, that would work as well. So if I'm looking for the reference angle and I take the inverse cosine, I'm not going to worry about that negative sign, and I'll find that theta ref is equal to 65 degrees. How do I reconcile those two? Well, 115 degrees, that's in quadrant 2. That's the value of theta 1. 65 degrees is the reference angle. 115 degrees plus 65 degrees, 180 degrees. So whether you use the negative or not doesn't really matter, but we have to be careful about interpreting the answer. If you use the negative 0.422, you're not given the reference angle. You're in fact given theta 1, the quadrant 2 angle. If you take the absolute value of 0.422 and take the inverse cosine of that positive number, you will end up with the reference angle. In any case, we know that theta 1 is 115 degrees. And even if we hadn't found the reference angle, we could calculate it by taking 180 degrees and subtracting 115 degrees. The reference angle on both sides will, of course, have the same value. So we'll have an angle of 65 degrees up here, as well as down from that negative x-axis. So theta 2 has a value of 180 degrees plus 65 degrees, or 245 degrees. And finally, here we have much more information. We have a key second piece. The sine of our angle is a negative value. Sine is, of course, positive in quadrant 1 and quadrant 2, so our angle is going to be in quadrant 3, we'll call that theta 1, or in quadrant 4, call that theta 2. That's if I only use the first piece of information. Secondly, we're told that the tangent is a value less than 0, a negative value. Well, tangent is positive in quadrant 1 and quadrant 2, so this rules out quadrant 1 and quadrant 2 because theta, or the tangent of theta, is negative. So we don't need to look at these two different angles. We know that the theta, the angle that we're interested in, is in quadrant 4. With that, reach for your calculator and let's find the angle. So we'll take the inverse sine of negative 0.192. Or you can take the inverse sine of positive 0.192. That will give us a positive reference angle. We can deal with either. So the inverse sine in this case is negative 11 degrees. If you'd use the positive value here, you'd have positive 11 degrees. Well, where is 11 degrees on our diagram? Well, it's the reference angle. But we could also label theta 2 here as negative 11 degrees. The only reason we're not going to leave the answer that way is because the question once again specifies that we should have a positive answer. So theta 2, really the only theta we're interested in here, so let's just call it that, is 360 degrees minus 11 degrees. It's 11 degrees short of going all the way around 360 degrees. So we have a value of 349 degrees.